actually feels like we're getting pushed farther away.
Oh yeah. Tractor beam. Suck me right in.
Can a beam of light really push you, pull you, or keep you in position? Is it really possible for light to do that? Can you even trust light to hold you in some position against the force of gravity? Yep, I don't think so. But the truth actually is that it can. Yes, a beam of light itself can move things around, and a certain type of beam can even hold things in place. Well, wouldn't that really imply that light has momentum? We all know that it does.
We all know that for a classical object, its momentum is defined by P equals mv. This is a problem with photons, which are considered massless, so we have to use the quantum mechanical and relativistic energies to then describe its momentum. This is using E equals hf and E equals pc, by which we can make P equals hf over c or P equals h over lambda, which will allow you to describe its momentum in terms of its wavelength, which will be quite useful in the optical traps, and there'll be more of that in the next section.
Let's imagine a microbead, a small glass sphere with optical properties. The bead's size is comparable to the wavelength of light that it is placed in. Place this bead into a laser. This laser is brightest in the middle and gets dimmer towards the edges. This is called a Gaussian beam, where the intensity of light peaks in the center and fades outwards as described by a Gaussian distribution. The light incident on the bead is refracted upwards and downwards as shown. This bending of the light changes the direction. Therefore, the bead must exert an impulse on the light and will feel an impulse on itself in response. In this position, the bead is displaced from the center of the beam. The intensity of the light it is refracting upwards is greater than the intensity of the light being refracted downwards. This means that there is a net impulse upwards on the light. The result is a resultant force downwards on the bead towards the middle of the laser beam. When the bead is placed in the center of the beam, the amount of light that is refracted upwards or downwards is equal. This means that there is no resultant force on the bead. This means that this is the equilibrium point, and the bead will feel a restoring force towards this position when displaced in any direction.
The Gaussian beam also pushes the bead in the direction of the propagation of the beam. There are two ways to eliminate this movement. First, let's turn the diagram 90 degrees. Now, there are two forces on the bead. Gravity will pull the bead downwards, while the light will push it upwards. If the right intensity of the laser beam is used, this will create a stable system. However, this is very difficult to achieve, and the bead will move up and down. Another option is to use a microscopic lens. The light beam is passed through a microscopic lens to converge the light to a focal point. The change in light's momentum will be in the same direction as propagation of light. The angle and direction of the light created means that the restoring effect described earlier will now act on the bead when displaced in any direction from the focal point.
An interesting use of optical traps is using them to measure the properties of biological molecules. This is done by attaching between 1 and 3 beads, and then measuring the positioning of the beads, and thus the extension of the biological molecule. And this shows you the force of the motor within the biological molecule. Another use of optical traps is to stop biological molecules in living animals. In one experiment, researchers actually stopped a red blood cell. And this has started to pave the way for micro operations where arteries can actually be unblocked. Amazing, right?
This discovery about optical tweezers actually resulted in Arthur Askhin winning the Nobel Prize in Physics in 2018. Since then, the discovery has paved way for so many possibilities. Imagine it yourself. We might soon be living in a world where lightsabers are a reality. Sadly, Arthur Askhin passed away a couple months before the making of this video, but his legacy will forever live on.